Okay, in today's video, I'm going to go over an example problem concerning voltage and current while charging a capacitor in a simple RC circuit. In this circuit we have a 12 volt DC source, we have a 10K ohm resistor, and we have a 470 microfarad capacitor. And we're going to answer the following four questions. What is the value of the voltage across the capacitor after two time constants? And what will the value of the voltage across the capacitor be after 6 seconds? So we're going to do a problem concerning time and voltage with time constants and time and voltage with just regular old time. And then the third thing we're going to do is we're going to determine how long it will take for the capacitor to be fully charged. What does it mean for a capacitor to be fully charged? And then we'll figure out what will the current through the circuit be, or when will the current through the circuit be reduced by 25%. All right, so the first thing we're going to do is what is the voltage of the capacitor across the capacitor going to be after two time constants? Okay, first of all, we have to figure out what one time constant is. The way we calculate the time constant, tau, is the symbol we use for the time constant. We just multiply the resistance of the resistor times the capacitance of the capacitor. And we get R times C, which is 10 times 10 to the third, because of a 10,000 ohm resistor, 10 to the third ohms, and 470 micro, 10 to the minus 6 is microfarads. And that gives us that the time constant, one time constant, is 4.7 seconds. We want to know after two time constants. Okay, now I'm just going to get out the equation we use to calculate the voltage with respect to time. It's just the voltage of the battery times 1 minus E raised to the power of minus T over RC. RC is our time constant, that's 4.7 seconds. We want to know two time constants. Now, two time constants is obviously going to be 9.4 seconds, and so I'm just going to plug those values in, or plug those two values in, which is minus 9.4 divided by 4.7, which is obviously 2, so we could have just gone here. I wanted to show you how that works with the time and the time constant, the two time constants. But you see we have 12, which is the voltage of the battery, times 1 minus E raised to the power of minus 2. Minus 2 because it's two time constants. And then we can just figure out that that is the voltage with respect to time is going to be 12, because that's the voltage of the battery again, times 0.864. Now if you remember that after one time constant, the voltage across the capacitor will be 63.2% of the voltage of the source. After two time constants, it's 86.4. After three time constants, it's like 95, and then 98.2, and then after five time constants, 99.3. But in this case, we had two time constants. You see that's 86.4% of the source, which tells us that the voltage across the capacitor for this circuit after two time constants will be 10.4 volts. All right? So that's with time constants, and then the next thing we're going to do is at a specific time, 6 seconds. RC is our time constant again, because we're going to use the same equation. 12 volts for the battery, 6 seconds, T is the time. RC is the time constant, which is 4.7 seconds. And then we get that's 12 times 1 minus E to the power of minus 1.28. And that tells us that after 6 seconds, the voltage across the capacitor will be 72.2% of the voltage of the source. And that tells us that the voltage across the capacitor at 6 seconds will be 8.66 volts. Okay? Basically the same thing whether using time constants or time, both time, same equation. Okay? All right, now the next thing we're going to do is figure out, what do we say, when will the capacitor be fully charged? Here is our value for the time constant. Now it's generally accepted that the voltage for the capacitor will be fully charged after 5 time constants. Okay, it's an exponentially increasing voltage across the capacitor. And after 5 time constants, it's actually charged to 99.3% of the maximum. And that is considered to be fully charged. So we're just going to multiply 5 times the time constant, 5 times RC, RC the time constant again, 5 times 4.7 seconds, and that tells us that the capacitor will be fully charged after 23.5 seconds. Okay, the capacitor is fully charged after 5 time constants. Okay, and then the last thing we're going to do is we are going to figure out when will the current through the circuit be reduced by 25%. Now, this is the equation we use to calculate the current with respect to time is equal to the maximum current, the initial current. Remember, in a capacitor, when you're charging a capacitor, current goes to its maximum and then decreases exponentially over time. So it's the maximum current times E raised to the power of minus T over RC. And we actually want to know when it will be reduced by 25%. That means we want to know when will the current be 75% of the maximum. So for this term, I'm going to substitute in 0.75 I0. That is the maximum current, the initial current, the current at time 0. And so that is 75% of the initial, and that's when it will be reduced by 25%. And then you'll notice I have I0 on both sides, so I can divide this whole equation by I0, and that gives me 0.75 equals E raised to the power of minus T over RC. And then the next thing I can do is take the natural log of both sides. Okay, if I take the natural log of E to the X, is just X. Well, X in this case is minus T over RC. So E raised the natural log of E raised to the power of minus T over RC is simply just minus T over RC. The natural log of 0.75 is minus 0.288. And I'm just going to substitute 4.7 in because 4.7 is the time constant as we calculated in the previous slides. And then I'm going to cross multiply, and then I'll multiply by -1, and I get that the time is 1.35 seconds. That is how much time it will take for the current in that circuit to be reduced by 25%, or as we said here, to be 75% of the maximum. Okay? So there you go. We did all 4 of those things. We calculated the voltage across the capacitor 2 different ways, using time constant and using just the regular old time. We figured out when the capacitor will be fully charged, how long it will take for the capacitor to be fully charged after 5 time constants. And then we figured out the current through the circuit, or when the current would be reduced by 25%. Okay, so there you go. Thank you very much for watching. I hope you found that helpful. If you did, please do all the following 3 things. Subscribe to my YouTube channel. Get all my excellent physics, chemistry, and math videos. Step-by-step science. Give me a thumbs up for this video and leave me a nice positive comment in the comment section. I always want to know what people think about the videos. Very helpful. Thank you, and we'll see you in the next video.